Section 9.5 is on solving rational equations and inequalities. So we did a little bit of this, guys. We did a little bit of this in chapter 1. These first two questions are definitely like chapter 1 questions. Okay. So we learned in chapter 1 that we could eliminate denominators by multiplying through by the least common denominator. So when we look at x over 12 plus 1/2 equals negative x over 6, we notice that all of their denominators could be changed to the same denominator, which would be 12. And you can combine, solve, like cross multiply and so on, and solve, and you would get x equals whatever. So we learned that we could actually shortcut this, and we don't have to multiply, or we don't have to get common denominators. We don't have to change them all to the same thing and have fractions throughout our problem. Instead, what we did is we multiplied everything through by the least common denominator, which is 12. So I shortcut it a lot, and I just do parentheses around all of it, and I multiply by 12. So what this means is every term is now being multiplied by 12. So what happens is when I have 12 on top and I have 12 on the bottom, they reduce out. So I'm left with an x. All right, and then I have 12 and I have 2, so I reduce and I get a 6. So I have plus 6 equals 12 and 6 reduce and I get a 2, so I have negative 2x. And I can solve it. So I subtract my x over, so I get 6 equals negative 3x. I divide by negative 3, and I get x equals negative 2. That is my answer. Okay, so this is just like what we did in chapter 1. So on the next one, my least common denominator would be 8. So I'm going to multiply everything through by 8. And eventually we get to the point where we don't have to write this middle step. We don't have to do 8 times x over 4 plus 8 times 3. Equals 8 times 7 over 8, because we can kind of see it in our head what's happening. You can see that we're distributing an 8 to every single term. Now, a lot of people I remember in chapter 1 kept forgetting they thought it was 8 over 8. It's actually 8 over 1. Okay? 8 doesn't go to the top and the bottom. So if you need to put the over 1 thing, you can. So my 8 and my 4 reduce out, and I'm left with a 2. So I have 2 times x is 2x. And then I have 8 times 3 is 24, so plus 24. And then the 8 and the 8 reduce out, and I get 7. So my new equation is 2x plus 24 equals 7. When you're trying to clear the fractions, you should not have any denominators on this step. After you're done multiplying through, it should just be nice, like a nice equation that you can solve. Good question. So then subtract the 24, so I get 2x equals 7 minus 24, so I get negative 17. So I get x equals negative 17 over 2. And that's your answer. Or you could say negative 9.5. Negative 8.5. Pretend I can divide. Emily gets a point. All right, next up. So this is a little bit harder. Okay, so this time we have rational expressions. We have things that have x's in the denominator. So we need to clear these denominators. So we do the same kind of thing. We multiply by what would be the least common denominator. So imagine we're back in 9.2 and we're just adding things together. If I have x plus 3 and I have x squared minus 9, well, x squared minus 9 factors into x plus 3 and x minus 3. So if I want to talk about my least common denominator, I would need the x plus 3, but I would also need an x minus 3, right? So what I'm going to do is I'm going to take that x plus 3 and I'm going to multiply, or x plus 3 and x minus 3, and I'm going to multiply into my entire fraction. All right, that is x plus 3 and x minus 3. Okay, and this is where I get kind of lazy, because really what I should do is I should take that x plus 3 and my x minus 3, and I should multiply it into every single term, and I should write that out. Like it should say x plus 3 times x minus 3 times 1 over x plus 3 plus x plus 3 times x minus 3 times 5 over x plus 3 times x minus 3. Do you guys see? It would be really complicated to write the whole thing, but we don't. Instead, we just write it once. And we think that we take this whole thing and we multiply it in to each individual piece. So don't get cancel crazy. Don't draw lines through everything and cancel. Because you need to be thinking about it in your head, because you don't want to cancel it and then forget that you have it for the next one. Do you guys understand what I'm saying when I say that? So here's what's going on. So I'm taking my x plus 3 times x minus 3, and I'm multiplying it into the first thing. So take your fingers and cover up your x plus 3 and your x minus, or x plus 3. Don't cross them out like I am. Just take your finger and cover them up. So you're left with x minus 3. Do you guys see? So we're going to have an x minus 3. Right? And then the next one, I'm taking my fingers and I'm covering up the x plus 3 the x plus 3, the x minus 3, and the x minus 3. I'm taking my fingers and I'm covering those up. What am I left with? 5. All right, and then I'm taking my fingers and I'm covering up the x minus 3 and the x minus 3. So I'm left with 2 and the x plus 3. So I'm going to have plus, or equals 2 times x plus 3. Do you guys see how we got that? All right, so I get x plus 2 equals 2x plus 6. Subtract the x, so I get x. Subtract the 6 over here. So I get, whoops. So I get x equals negative 4. And that's your answer. All right, so let's do the same thing on the next one. So on your 9.2 homework, a lot of you guys went too far. A lot of you saw things like 2x minus 4, and you were like, oh, I need both the 2x minus 4 and the x minus 2 as my least common denominator. And you wrote that. You said my least common denominator is going to be 2x minus 4 times x minus 2. And you had really complicated things in your homework. Don't do that. Okay, we don't want it to be that big. We want to recognize that this very first thing, 2x minus 4, is really 2 times x minus 2. So when I come up with my least common denominator, I just need 2 times x minus 2. So I'm going to multiply that denominator, or that least common denominator, 2 times x minus 2, by my whole fraction. I cannot talk today. X over 2 times x minus 2 minus 2 equals 1 over x minus 2. So I'm going to multiply it in. So when I multiply in the first part, my 2 is going to reduce out, my x minus 2 will reduce out, I'm just left with x. So don't cancel it like I'm doing on this little projector, right? I just want you to see that you're just left with x. Right? Now the next one is going to be negative 2 times, I still need my 2 and I still need my x minus 2. And then equals 2 times x minus 2. So I'm going to have x minus, and this becomes 4, so I'm going to multiply my 4 in. So I'm going to have minus 4x, and then I'm going to have plus, because negative 4 times negative 2, so plus 8, equals 2x minus 4. Yes?
On the last one, if you multiply by 2x minus 2, would the x minus 2 cancel out? And then
Oh, yes, you're right. Thank you. So yes, you do get 2 here. Thank you. You guys just aren't, I was just checking. She's getting a bonus point. I just want to make sure you guys are still awake after lunch. My belly's a little full. I'm getting tired. All right, so I have negative 3x plus 8 equals 2. So I get negative 6 and negative 3x. So I get x equals 2. All right, but that's not actually the solution. What is the solution? No. There is no solution. What happens? Yeah, what happens when you plug it back in? When you plug it back in, you divide by 0. You have 1 over, it would be right here, 2 minus 2. 1 over 0. Doesn't work. All right, and it also works, it doesn't work here either. This is 4 minus 4. Right, so when that happens, it's no solution. That's called an extraneous solution. So we cross it out and we write no solution. Okay, so it's an extra solution, a solution that we came upon, like we got it, but when we went back and checked, it didn't work. So do any of the other ones have extraneous solutions? No, getting x equals negative 4 was fine because the things that were bad here were x equals 3 and x equals negative 3. That's what we can't have, right? And we didn't get either one. And then the other ones were just numbers on the bottom, so I wasn't going to get something that was bad either. Okay, next up. So on this one, I have a denominator, which is x squared minus 1. Well, that factors into x plus 1 and x minus 1. So that's going to be my least common denominator. So I'm going to multiply the entire fraction, my entire, not just fraction, but my entire equation by x plus 1 times x minus 1. So on the first one, my x minus 1s are going to cancel, so I get 4 times x plus 1. On the next one, my x plus 1s cancel, so I have negative 2 times x minus 1. And on the last one, both the x plus 1 and x minus 1 cancel, so I get 35. So I have 4x plus 4 minus 2x plus 2. A lot of people will forget the plus 2. Don't forget you have the negative 2 that is multiplying into both of them. All right, equals 35. So we get 2x plus 6 equals 35. Subtract the 6, I get 29. Divide, I get x equals 29 over 2. And that's our solution. All right, so this next one, there's a squared there, right? So I'm going to, so it's 5 over x minus 1 equals 4 plus, and this is x over x minus 1 squared. There's a little square there. I think it's covered up by my little video thing. I don't want to click it though, because then the video thing will come on. Yeah?
Why is it not 5x over x minus 1 equals 4?
You just forgot your x on the 5.
Oh, I forgot the x. Is that what I
That's
did?
what I heard in my hand too.
I don't know. I'm very tired. This daylight savings time, man, it's rough. Especially on my children. My boys woke up this morning and they were like, the 2-year-old goes, "It's dark outside." No, it's not time to wake up. So I was like, I know, I feel you. All right, anyway. I know, we can. All right, x over x minus 1 times x over x minus 1 is going to be x squared over x minus 1 times x minus 1. Okay? So I'm going to leave it factored like that. I'm not going to actually FOIL it out. So my least common denominator is going to be x minus 1 times itself. So x minus 1 times x minus 1. So I'm going to multiply that on both sides of the equation. So I get 5x, and then my x minus 1's cancel, right? Like this one and this one are gone. So I still have another x minus 1. So I'm going to have times x minus 1. And then equals 4 times x minus 1 times x minus 1. Nope. And then the next one I'm going to have x squared, and then the x minus 1's cancel on the top and the bottom. Okay, so I get 5x squared minus 5x equals 4 times x minus 1 times x minus 1 is going to be x squared minus 2x plus 1 when I FOIL it out, plus x squared. So I get 5x squared minus 5x equals 4x squared minus 8x plus 4 plus x squared. Go down here. So I have 5x squared minus 5x equals 5x squared minus 8x plus 4. So this is actually kind of nice what I gave you. Yes, there are x squareds and x's, but you actually don't need to factor in order to solve. Because the nice thing that happens is when I subtract 5x squared from both sides, the x squareds go away completely. So we have a nice linear equation then. So I have negative 5x equals negative 8x plus 4. So I get 3x equals 4. So x is 4/3. Is that okay? Look back at your original. What could you not have for x? 1. That's the only thing, right? So getting 4/3 is fine. So these ones are very easy to check. You don't have to go through the full check step where you're plugging in and seeing if it makes a true statement or not. You're just checking to make sure it didn't make an undefined. So that's what it's saying at the bottom. It says an extraneous solution is a derived solution that is not a solution of the original equation. So when you go back and you check in the original, you get something divided by 0. Okay. So were there any extraneous solutions above? Yes, number 4 had an extraneous solution, and I told you about that already. So yes, over 4. All right, next up. So it says sometimes it helps to multiply a fraction by -1 over -1 in order to have the factors of the common denominator. So I'm going to try to explain this. So I said, for instance, maybe you have x squared minus 4 on one denominator. But then on another denominator, you have 2 minus x. And then another one, you have x plus 2. Right? So let's say you have that. Well, x squared minus 4 factors into x plus 2 and x minus 2. But this 2 minus x is totally throwing us off. Because you can't have that 2 minus x. It needs to be x minus 2. So we talked about this on the on section 9.1 when we were canceling things. Remember I told you if you had like a 2 minus x, and then you have an x minus 2. Remember I told you to cancel them? Like go ahead and cancel them. But I said make that a -1 because they were opposite each other. And we talked about factoring out the -1. Do you guys know what I'm talking about? You're looking at me like I'm speaking another language. Yes? So what we're going to do here is we're going to multiply by a -1 over a -1. And it's going to make it, instead of 2 minus x, it's going to make it x minus 2 on the bottom, which is good. Okay, so if you have something and you're like, man, that's kind of weird, see if you can multiply by a -1 over -1 to make it nicer. Okay, so on this first one, so I have x plus 1 and I have 1 minus x. You could go with it like that. Like you could use x minus 1 times 1 minus x as your least common denominator. It's just kind of weird. Like we like when it's x minus 1 times x plus 1, right? Because they're, when you FOIL them out, you get x squared minus 1. You know what I'm saying? So let's go ahead and we're going to take this and we're going to multiply by a -1 on the top and the bottom for just this fraction, just that second fraction. So when I do that, I get 3 over x plus 1, and I have -3 times -1. So I have plus 3 over, and it's -1 plus x, so it's the same as x minus 1. It swishes it around. Equals 4. So everything else about the equation stays the same. Do you guys see what it's plus 3? Is that a minus 3 up front? All right, so my least common denominator is then going to be x plus 1 times x minus 1. There you go. So when I multiply, my x plus 1's cancel. I have 3 times x minus 1 plus the next one, the x plus 1's cancel, so I have 3, or sorry, the x minus 1's cancel, so I have 3 times x plus 1. And the last one, I'm going to have x plus 1 and x minus 1 times the 4. So I get 3x minus 3 plus 3x plus 3 equals 4 times x squared minus 1, right, when I FOIL it. So I have 6x, and then minus 3 plus 3 goes away, equals 4x squared minus 4. And I was a little bit alarmed on the last test because I gave you some like this where you had to solve, like you had to have it set equal to 0, you had to factor and so on, and you guys did not know how to solve this. It scared me a little bit. You like were doing things where you're like pulling out the 4, setting it equal to 6x, taking the square root, like just here. I don't know what you were doing. It was crazy. Don't do that. If you have an x squared and you have an x term, you want to get everything on one side, set it equal to 0 so you can factor. So we're going to have 0 equals 4x squared minus 6x minus 4. So we could pull out a GCF of 2. So I have 2x squared minus 3x minus 2, which makes it a little bit easier to factor. So I'm definitely going to need 2x and x. And I want my outer and inner swoops to combine to be -3. But I want my last numbers to multiply to be -2. So I need a 2 and a 1. But I need them like that. So I need negative and positive. So I have 2x plus 1 times x minus 2. And it's all equal to 0. The whole reason we do that is because we use the zero product property. We say like 2 equals 0. Well, that doesn't give us anything. What about 2x plus 1 equals 0? That does. X minus 2 equals 0. We get answers of -1/2 and 2. Those are our two answers. So -1/2 and 2. All right, you guys try number 2. So I'll pause for a second so you guys can try it. All right, so I just told you guys there was a typo there, so don't forget that you have a plus on that one. All right, so as you're doing this problem, give myself some room. So we notice that we have a 3 minus x, and we really want x minus 3 because we're noticing that x squared minus 9 is x plus 3 times x minus 3. So if this was x minus 3, we would be good. So we're going to multiply by -1 over -1. So our first step is going to be, we have -x minus 3 over x minus 3 plus 3x plus 1 over x plus 3 times x minus 3 equals 5x plus 1 over x plus 3. And we're going to multiply all of that by the least common denominator, which is x plus 3 times x minus 3. So when we do that, the x minus 3's cancel on the first one. So I have x plus 3 times negative x minus 3 plus, the next one both cancel in the denominator, so I just have 3x plus 1. And the last one I have negative, sorry, not negative, I have 5x plus 1 times x minus 3.
Would it be x minus 2, not x plus 2? Oh, I know.
Okay. So I'm going to have negative x squared minus 3x minus 9 plus 3x plus 1 equals 5x squared minus 15x plus 1x minus 3. So we're going to clean it up a little bit. So I have negative x squared minus 3x, those cancel, minus 8 equals 5x squared minus 14x minus 3. So it's not like the one we did where the x squareds just go away. When we subtract 5x squared, it goes away. Doesn't work, right? We need to get everything on one side. So I'm going to add the x squared over, so I get 6x squared. I need to add the 3x over, so I get negative 11x. And I need to add the 8, so I have plus 5. And that factors. So you have 6x and x. You need 5 and 1. And they're both negative. So you guys get this? Okay, so set each one equal to 0. So you get answers of 5/6 and 1. And both of them are good. Neither one made undefined. The only things you couldn't have as answers were 3 and negative 3. Okay, so those answers work. Does that make sense? Okay, so those are all rational equations. That's about as hard as it gets for the equations. All right, inequalities. Inequalities are going to be kind of like what we did with quadratic inequalities. Do you guys remember that? We did it in chapter 5, I think. Chapter 5, 5.7 maybe. That's when we had critical values. So we put things on a number line, and we tested on the left, in the middle, on the right. Do you guys remember those? Okay, that's what we're going to do here. So we need to find critical values. So in order to do this, we're going to first set the two sides equal to each other. So we're going to have x over x minus 6 is equal to 3. That's going to get our first critical value. Now I don't need to multiply through by the least common denominator and all that. You guys know how to solve things like this. You just take the denominator and you multiply it to the other side. So you get x equals 3 times x minus 6. Same with, a lot of people like freak out when I give them something like this. Right? You can cross multiply. You guys know how to do those things. So same idea. All right, so I'm going to get x equals 3x minus 18. Subtract the 3x over, so I get negative 2x equals negative 18. So I get x equals 9. That's the first critical point. So in the instructions it said find the value of x that makes the two sides equal. So we did that. And then it says also make sure you check to see what makes the denominator equal to 0 as well. So our second critical point comes from setting our denominator equal to 0. So any denominators that we have in our problem that have x. So in this case, I have x minus 6. I need to set it equal to 0. So I get x equals 6. Those are the two numbers where something weird happens, okay, where it's either undefined or 0. Okay, so I need to, or equal, I guess I should say. So I need to put those numbers on the number line. Then I test in each interval around it. Okay, so I'm going to test on the left, in the middle, on the right. And a lot of these you can do in your head. So if I'm testing, I don't know, like 5 or 0 even. 0 of 0 over 0 minus 6 is less than or equal to 3. 0 over negative 6 is 0. Is that less than or equal to 3? Yeah, 0 is less than or equal to 3. That works. Then I try 7. So I have 7 over 7 minus 6. Is that less than or equal to 3? So 7 over 1, right? 7. Is that less than or equal to 3? No. And 10, so I have 10 over 10 minus 6. Is that less than or equal to 3? Well, that's 10 over 4. 10 over 4 is 2.5. Is that less than or equal to 3? Yes. So I'm going to shade both of the places where I have the check. So I shade there and there. But then I consider the endpoints. Previously with the quadratic inequalities, if it said less than or equal to or greater than or equal to, we filled both of them in. But we do not here. Okay, think about it. If I plug in 6 into the original, What do I get when I plug in 6 for x? I get 6 over, over 0 is undefined. It doesn't work. 6 divided by 0, I don't know what that is. I don't know if it's less than or equal to 3. I have no idea. It's undefined. So it's going to be an open circle on 6. But what about 9? What happens when you plug 9 in? You get 3 is less than or equal to 3, which is true. It is less than or equal to 3. So that's the one that made it equal, so that's included. The one that made it undefined is never included. So your interval notation would be negative infinity to 6, parentheses, union, bracket, 9 to infinity. And that's it. Okay, same thing on the next one. Okay, so I first set it equal. I multiply over, so I get 3x. 3 times x minus 8 is 3x minus 24. I add the 24 over, so I get 30 equals 3x. So x is 10. That's my first critical value. What's my other critical value? Yeah, I need my denominator equal to 0, so I have x minus 8 equals 0. So I get x equals 8. I put both of those numbers on the number line in order, right, 8 and 10. And then I test each location to see if it gives me a true statement or a false statement. It doesn't matter what number I'm picking in each location. So I want to pick something smaller than 8. So I could pick 7. I could pick 0. It doesn't matter. So if I try 0, I get 6 over negative 8. 6 over negative 8. Is that less than 3? Yep. What if I try 9? 6 over 9 minus 8. 6 over 1. Is that less than 3? Nope. What if I try 11? 6 over 11 minus 8 is 3. That's 2, right? 6 over 3? Is 2 less than 3? Yep. Shade, shade. What about the endpoints on this one? Both of them are open, right? Both of them. Why both this time? Yeah, it didn't say less than or equal to. So even when I plug in 10, I get 3 is less than or equal to 3. Or sorry, I get 3 is less than 3. It did not say 3 is less than or equal to 3. 3 is not less than 3. Okay, so it wouldn't be included. So my interval notation is negative infinity to 8, parentheses, union, 10 to infinity. All right, so I think the ones I gave you on your homework are mostly like this, like where they're just nice ones where it's pretty easy to multiply over and so on. But I think I do give you one that looks like this. Okay, this one's kind of messy. It's a lot worse than the one on your homework. It's like negative 13 thirds or something. Okay, so anyway.
Wait, what was the rest of the answer?
Yeah, did you get negative 13 thirds? So on number 3, so we're going to first set it equal. So when I set it equal, I'm going to multiply through it by the least common denominator, which, as you can see, is x plus 2 times x minus 2. I'm going to multiply everything through by that. X plus 2, x minus 2. So when I do that, the x minus 2's cancel, so I have 4 times x plus 2. Plus 3, right? Both cancel, x plus 2, x minus 2. Equals 1 times x minus 2, so just x minus 2. So I have 4x plus 8 plus 3 equals x minus 2. So 4x plus 11 equals x minus 2. Subtract the x over, I get 3x equals, subtract the 11 over, negative 13. So x is equal to negative 13 over 3. So that's one of my critical values. What are the other two critical values? Yeah, they come from setting your denominators equal to 0. So x plus 2 equals 0 and x minus 2 equals 0. So I get x equals negative 2 and x equals 2. So negative 13 over 3 is a little bit more than negative, or a little bit less than negative 4. Negative 2 and 2. And I test in each location. This is where it gets kind of messy. And it was nice, like your homework I didn't make like a weird fraction like this, but. Okay, so I can test in the original. So if I try 3, I'm going to have 4 over 3 minus 2 is going to be still just 4. Plus 3 over 3 squared is 9, minus 4 is 5. Is that greater than or equal to 1/5? Yeah, 4 3/5 is bigger than 1/5, right? So we're good. All right, what about 0? 4 over negative 2 is negative 2. Plus 3 over negative 4. Is that greater than or equal to 1/2? No, this is a big negative number, right? Doesn't work. All right, then it gets a little bit harder. So let's try negative 3. 4 over negative 3 minus 2 is negative 5. Plus 3 over negative 3 squared is 9, minus 4 is 5. Is that greater than or equal to 1 over negative 1? So this is negative 4/5 plus 3/5. So that's negative 1/5. Is that greater than or equal to negative 1? Think about it. 0, negative 1. Here's where negative 1 is. Where's negative 1/5? It's right there. It's bigger than negative 1. It's hard with negatives, isn't it? So this does work. And then when you do something on the left, like negative 5, you end up getting this doesn't work. I won't do it for you, but it doesn't work. It doesn't always alternate. Don't just assume it alternates. But I've already checked it in 3 other class periods. So we're good. All right, so we're definitely shading the places where we have the checks. Endpoints. 2 and negative 2 cannot be filled in. Those are what made it undefined. So those are open. What about negative 13/3? That's what made it equal. Could I be equal? Yeah, it said greater than or equal to, right? So that's good. So your answer is bracket negative 13 over 3 to negative 2, parentheses, union 2 to infinity. That's your answer. So you can do the challenge if you want. If you bring it to me and you have it correct, I will give you a bonus point. You can bring it to me tomorrow too. You don't have to do it today. I think it's the shading is weird. I don't remember. It's been a while since I've done it.